So we're continuing our Unit 6 fraction unit this week, and we have been really busy comparing and ordering fractions. So I had sent that video last Friday to kind of show you some strategies that were being taught in class, and the kids were able to kind of pick and choose which strategies work best for them. I did introduce a new strategy to them called benchmarking, so they can utilize those benchmark strategies. Now they know how to do it. That was a part of the video too, so if you need a refresher, you can go back and look. So starting on this Friday, we are going to be looking at improper fractions and changing them over to mixed fractions, having mixed fractions and changing them over to improper fractions. So I'm going to show you a couple of strategies that kind of helps the kids really understand what's taking place when you're taking an improper fraction and you're going to a mixed fraction and vice versa. So in this first one here, I'm going to show you some strategies where we're taking the improper and we're going over to the mixed. To get them kind of started, we talk about decomposing a fraction. And what that means is breaking it apart, so breaking it down. So if you have 9/4, some kids really don't understand what 9/4 really means. Like, what does that entail? What does that really look like? So I showed them with the decomposing strategy that 9/4 really is 9/1/4. Okay, so that's where I'm kind of breaking it down and showing them that that's where I'm getting my denominator from. It's out of fourths, and there are 9 of them. So I have it written out this way. The reason you see these boxes here is because I'm going to box every time I hit one hole. So I'll ask the kids, well, how many fourths does it take to hit one hole? And they should know that it's going to take 4/4. So that's why I came down and I boxed it. I can also do another 4/4 and box it. And what I have left over is a fourth, because obviously that's not enough to make a hole. So 9/4, when I decompose it and I find the holes through, my decomposition, I'm going to end up getting two holes with 1/4 left over. If I do the same thing with an example of 6/3, that 3 tells me what my denominator is, what I'm breaking it into. So I'm breaking it up into 6/3. So here are my 6/3. And again, when I'm trying to create whole numbers here, I got to think, well, how many thirds is it going to take to hit a hole? And the kids are going to say 3 out of 3. So 1, 2, 3, there's one hole. 1, 2, 3, there's another hole. So 6/3 gives me exactly 2. I don't have any fraction pieces left over. So again, I teach this one first just so that they can really understand what's happening with an improper fraction. Another strategy that I use, and I'm going to use the same examples up at the top with this second strategy so you can kind of understand. This one is where you're kind of subtracting the whole from the original improper fraction. For example, if I have 9/4, the kids know it's out of fourths because my denominator tells me this. So if I want to take away to keep reducing it down to where I have whole numbers and what's left over, I can take one whole away from 9/4 because I have enough to do that. So again, the reason how I knew to put 4/4 is because that denominator told me that. So I'm going to take away 4/4. And I'm going to box it showing that I took a whole away from this original fraction. I'm left with 5/4. Well, do I have enough to take another whole away from 5/4? Yes, I do. So here's 5/4. I'm taking another whole away, and I'm left with 1/4. So when I go back and look and see what I've done, I've noticed there are 2 holes, and there's 1/4 left over. Okay, very similar here. So I get the same answer. I just chose a different strategy. Here I decomposed it and boxed it. Here I was aware of what I could take away. Same thing with 6/3. So I use this 6/3 example. I'm coming down here. How do I know to subtract 3/3? Because again, my denominator told me that. So when I subtract, I'm left with another 3/3. So I can take this away. So I'm taking it away. I have no fractions left over. So it creates again the 2 wholes that I was able to take out from the 6/3. So this is another little strategy they can use if they like. Instead of drawing the picture, they can subtract it. Because the higher your numerator, it's going to be really long to decompose. So subtracting may be a faster strategy for them, because if I had, for example, 32 as my numerator, you're not going to want to write out 32/4. That could take a really long time. So this one might be faster. So really, this strategy is really good for if you have a lower numerator number. This one could be good if you had a higher one, just having to subtract. Another one is the way you were probably taught, which is the old school way, is what I tell them. Okay, it's that old school way that you were taught when you were coming through elementary school. And this is the fast, efficient way. And I always teach the decomposing and subtracting first before I hit the old school, because the decomposing and subtracting, again, really has them understand what's happening in the improper fraction. Whereas in the old school, it doesn't tell you that. I mean, it just tells you this process of dividing, and this is what you get, and that's it. So they don't really understand where 2 1/4 is coming from. But I do teach this also after I've taught the other two. But you simply divide the way you did it when you came through. Obviously, 4 can go into 9 2 times. 2 times 4 is 8. I subtract. I'm left with 1. It swings up, and that 1 now becomes the numerator back over the denominator, and 2 is my whole. Same thing with 6/3. I subtract, and I'm left with 2 whole. So again, old school way really doesn't explain what's really taking place with 9/4 or 6/3. That's why I save it for the very end. However, it is very fast, it is very efficient, and parents know how to do this way. So those are 3 strategies that I teach them when we're looking at improper fraction to mixed. Then when you're going from a mixed fraction to an improper, the first thing I showed them is a fraction model, because again, I want them to understand how they're really changing the mix to an improper. So we create a fraction model. So I'm going back to 2 1/4. I'm doing the opposite now at this point. And I'm showing them that, again, my denominator is very important, because that lets me know what I'm breaking my fraction model into. Again, I'm breaking it into fourths. Well, when I draw my fraction model, I have to make sure I have enough, okay? And because this is out of fourths, I know I'm breaking it into fourths. And because it's 2 1/4, I know that I need at least 2 full bars, and I'm going to need another bar to show a fourth. So I'm going to draw out 3 bars, and I'm breaking it into fourths. And then I'm literally going to shade what I see. 2 whole 1/4. And then I go back and count. 1, 2, 3, 4, 5, 6, 7, 8, 9. There is 9 fourths here showing. So I'm literally showing 2 1/4 is the same thing as 9 fourths, but in a fraction model. If I were to have 3 2/3, how do I know what to break my model into? I look at that denominator. It's broken into thirds. Okay. How do I know how many of these I'm going to need? Well, I know I'm going to need at least 3 fraction models, and then I know I'm going to need another one to show 2/3. So again, I draw them out, I break them into thirds, and then I literally shade what it shows. 3 and then 2/3. And then when I count, it's going to be 11 thirds. Okay, so again, I show this strategy first, just so again, they can understand where I'm getting the numbers from. Okay, that's important for them to have that understanding. And then there's the old school way. Again, the way you were taught. I showed this next, and then this is a quick, efficient way. So again, if I had 2 1/4, that old school way that you were taught, 4 times 2 is 8, plus 1 gives you that 9 back over the 4. I need to change that. So that gives you 9 fourths. Okay, so again, you kind of just swing it. And then here, same thing. If I have 3 2/3, 3 times 3 is 9, plus 2 gives you the 11 back over the 3. But again, when you do the old school way, it doesn't explain anything. So it's just about the process, but the kids really aren't understanding, you know, why are you taking the denominator, timesing it by the whole, and then adding it back to the numerator. It just doesn't show it like it does in a fraction model. So all of these strategies I'll be showing in class on Friday, and we'll be practicing it next week. So if you have any questions, feel free to reach out. Thanks.